Okay, let's go through these questions. So we are given the equation y equal to 2 e to the power of 2 minus 2x minus 5 e to the power of negative x. So we will be asked to determine how do we actually determine the asymptote. Okay, so maybe let's do a very quick recap on our rational function first. So if I'm given a rational function, let's just say y equal to fx over gx, I can actually make it into this form such that I'll get y equal to the first bracket plus something over something, right? So where this part will be either your horizontal asymptote or your oblique asymptote. Then of course for the vertical asymptote is actually the denominator right here. Okay, so of course by one look, right, you notice that this equation right here, we cannot form the so-called the standard form. So what we can do, right, is to maybe analyze using the definition of asymptote. For example, so if I look at the definition of vertical asymptote, so vertical asymptote is actually the value of x. Of course, the x must be of some finite value, not infinite. So for example, x equal to 1 or 2, so and so forth, such that y is actually undefined. So it means that y will actually blows up to infinity. Okay, so to do this, I can maybe rearrange the equation to be as such. So for example, right, y equal to e to the power of 2 over e to the power of 2x minus 5 over ex. So you notice that from all real values, so all finite real values, right, there is no such value of x such that y will tend to infinity, except for this value. So for example, as x tends to negative infinity. So as that x tends to negative infinity, we know that e to the power of, let's just say, negative infinity will tends to 0. So meaning that this part and this part will tends to 0. So means that the whole of y will just become infinity. But since we know that, x tends to negative infinity, this is not of finite value. Meaning that there shouldn't be any vertical asymptote. So yep, so that is the very first part. Okay, what about the second part, horizontal asymptote? Horizontal asymptote is where the behavior of y, where y is of course another finite value as x tends to positive infinity and x tends to negative infinity. So let's determine the positive infinity first. So for example, y is equal to e to the power of 2 over e to the power of, let's just say, 2 infinity. I just put infinity. Minus 5 over e to the power of infinity. So this whole thing, the e to the power of infinity, right, will be tending to a very big value, infinity. So this e to the power of 2 divided by infinity is just 0. And this one also 0. So means that your y, right, will be tending to 0. So this is one of the asymptote. Because y tends to 0, this 0 is of some finite value. So that's why y is tending to 0 is the horizontal asymptote. Okay, so of course, let's determine y equal the negative infinity. Y equal to e to the power of 2 over e to the power of negative infinity minus 5 e to the power of negative infinity. So this e to the power of negative infinity, we know this thing right here will be tending to 0, a very small value, such that the whole of this will be blowing up. So means it's like tending to infinity. Then same thing, this one also tending to infinity. Means that the y value right here, right, will be tending to infinity. So of course, this is not of finite value. Means that the only asymptote that we are looking at, right, is y equal to 0. So with this, right, maybe I plot the graph so that it's easier for us to see. So for example, I plot this function. Then after that, I graph it. And of course, maybe I just zoom standard first. So if you look at the x tending to negative infinity, the y is going to infinity as well. However, if you look at x tending to positive infinity, right, so you can see that the y value is tending to of some finite value. Let me just zoom box it. Sorry. Okay, so like that. Okay, so you can see that the graph is tending towards y equal to 0. So there's one asymptote here. So that is how we actually determine the asymptote of some exponential function.